This video is about homework 33 in questions 129 through 131. And we're looking at a college visit where we have 240-mile car trip. And if we look at miles divided by hours or miles per hour, we'll get miles divided by hours, miles per hour. And our miles was 240. And let's just take an example. For example, if you look at the time of 12 hours, 240 divided by 12 is going to be 20, which is our answer on our table. Now we're supposed to fill out the rest of the table. You can do it the same way. So if we look at 8 hours, well, what is 240 miles divided by 8 hours? That's going to be 30 miles per hour. If you divide it by 6, it'll be 40 miles per hour. Divided by 3, it's going to be 8 miles per hour. 80 miles per hour. Divided by 4.8, and it'll be 50 miles per hour. Very straightforward here. What may not be so straightforward is what happens when you have the speed. What do you do then? Well, the miles per hour. What do you need to divide 240 miles by to get, say, 60 miles per hour? Well, you could also look at this, do the inverse operation to get that question mark by itself. It's 240 divided by 60 is miles divided by miles per hour, which will give you units of hours. 240 divided by 60 is 4. So we fill in the rest of the chart, some of it, and I'm going to leave the 25 for you to try to do. In R, if I do 240 miles divided by R miles per hour, that will give me the number of hours. We go to graph this, so let's graph some of the points. I'm at 20, I'm at 12. If I'm at 40, I'm at 6. I'm at 50, I'm at 4. I'm at 60, I'm at 4. And if I'm at 80, I'm at 3. And 15 will give me, I'm at 16. Notice this is a curve. This is not a line. This is an inverse curve. And where the R is on the bottom. This is called an inverse function. So in the second problem here, Pat bought several pens. We're going to let W be the number of pens that she bought at Walgreens. So 42 is the total number of pens, and that's going to be your W plus some number. If you solve for that number is going to be the amount of pens that she bought at the bookstore. That's going to be 42 minus W, the number of pens bought at the bookstore. There's a few ways of looking at this. The first one, let's just look at, say, 60 cents per pen. If you multiply that by the number of pens, W, you're going to get dollars. And I don't know what that is. It's 0.6 W, but it's going to be in the units of dollars. And this is going to be important to us when we start thinking about what do you do with this 0.8 cents per pen? Well, we know that they have the same, they're both the same amount of money. So 80 cents per pen, if you invert it, if you flip it, that'll give you 1 over 0.8 pens per dollar. When I multiply the pens per dollar times dollars, it'll give me the number of pens that Pat bought at the bookstore. So my dollars, though, I'm going to use this expression that I came up with earlier, 0.6 W. I don't have the W here yet. I'll put down the W. 0.6 W. And I get 0.75 W is the number of pens bought at the bookstore. It's the same as 3 over 4 W, pens bought at the bookstore. So the total pens is 42 pens, and if we add the 1 W plus 3/4 W, I have to get a common denominator here. I'll do 4 over 4. I'm going to have 7/4 W is equal to 42. And we can isolate the variable by doing the inverse operation. We'll start by dividing by 7, or multiplying by 1/7. Multiplying by 1/7 is the same as dividing by 7, folks. So here we have 6 is equal to W over 4. Multiply both sides by 4. And I'm trying to isolate the W, get it by itself. W is equal to 24. But W, remember, is the number of pence from Walgreens. We want the number of pence from the bookstore. So we'll take our 42 minus 24 to get 18 pence. A second way of doing this, well, again, we'll start with W being the number of pens bought at the book at Walgreens. There's 42 pens in all, so 42 is my W, pens at Walgreens, plus the pens at the bookstore. The number of pens at the bookstore is 42 minus W. And we're going to use these two values along with the fact that if you look at dollars per pen times the number of pens, that's going to equal to dollars. Now the dollars is the same amount. Well, how much dollars did you spend at Walgreens pens? 0.6 times W. That's the dollars per pen times the pens. And at the bookstore it was 0.8 times the quantity, 42 minus W. Now, I want to get rid of the parentheses, but I also want to get rid of the variables. I'm going to do this division first. Can I do that? I don't have to distribute first. I could just divide both sides first. And this gives me my familiar 3 over 4W. 3 over 4W is equal to 42 minus W. I'll add W to both sides of this equation, which of course I'm going to add 4/4 W to 3/4 W. 4/4 being 1 W. And I get 7/4 W is equal to 42. Same as what we had before. So in this equation now I can divide both sides by 7 or multiply by 1/7. And I get W over 4 is equal to 6. And multiply both sides by 4 to get W equals 24. But remember, W is the number of pens at Walgreens. And we want the number of pens from the bookstore. So we want 42 minus W, which is going to be the same as 42 minus 24, or 18 pens. And I was thinking about this last night. I was thinking of another way to do it, and I'm going to make a table of values. So I'm going to have the number of pens and the dollars per pen. And we'll start with the ones from Walmart. The cost of these was 0.6, and the dollars that it cost for 1 pen is 60 cents. For 2 pens, it was $1.20. For 3 pens, $1.80. For 4 pens, $2.40. Now I need to extend my table a little bit, and I'm going to look again at dollars, but I'm also going to look at the pens from the bookstore. It said it's going to spend the same amount of money, and I know my cost for these is going to be 80 cents per book. So the question is, how many pens can you buy for 60 cents? Well, you're not going to get a full pen. But watch what we do here. If I take the dollars and I multiply by the number of pens per dollar, that'll give me the number of pens. Well, 0.6, and I flip this 0.8. I get 1 over 0.8. That'll give me the number of pens. And here, 0.6 divided by 0.8 is 0.75. That's 3/4 of a pen. I've also got, for 1.2, I'm going to get 1.2 divided by 0.8, which is 1.5 pens. Still, I haven't got a full pen. If I do 1.8, 1.8 divided by 0.8 is going to give me, I think it's 2.25 pens. 2.25 pens. Yeah, that's right. It goes into 18 twice to get 16. It goes into 20, 25. 25 pens. And then if I go 2.4 divided by 0.8, I'm going to get 3 pens. And this is important. 3 pens is a nice number, and it's a whole pen. And what this means is that for every 4 pens that I buy at Walmart, I'm going to buy 3 pens at the bookstore for the same amount of money, because they're the same. And I need to know a total of 42 pens. So if I scale up the number of pens from Walmart and the number of pens from the bookstore by 6, then I'll get 6 times 7 is 42. So I'm going to get 24 pens from Walmart and 18 pens from the bookstore, which is what we were looking for. Remember, that's what we were wanting to get in the first place. our last problem, you're building a house, and the Waukee building code says the maximum it can be is 35. And the architect wants to do a roof that's sloped by 10 inches for every foot of the run in the horizon. And so there's a few facts about this. And this is all about rate. This is all about rate in context of a problem. So we know that the center of the roof is at the center of the foundation. So this is 15 and 15 feet. We're at 22 feet. How tall can the roof be? And how tall will it be if I use a 1 foot for every 10 inches rise? And so we know, like again, this half of this is 15 feet. My rise, I'm not quite sure what that is going to be. I know it's going to be 1 foot for every 10 inches. 10 inches high for every 1 foot. So for 2 feet long, it's going to be 20 inches. 3 feet, it's going to be 30 inches. And how far would it be for 15 feet? 15 feet would be 150 inches. Well, let's convert that to feet, just to be on the safe side. 150 inches. If I multiply that by feet per inch, well, I don't know what feet per inch is, but I know what inches per foot is. So I'll write it 12 on the bottom and 1 on the top, using my units to solve this. And I get whatever this x is. Now, how high can it be? Well, the most it can be is 35 feet. And if I take my 35 and I subtract from it the 22 feet that I know I've got from the side of the house, then it's going to be a maximum of 13 feet. This is allowed. So going back to my problem, I get 12.5. I wrote down 12.6. It's 12.5. And so I do have enough here, and that's good. Now, this distance from these extra beams is 6 feet from the center. And we've got 15 feet from the center to the edge, to the point. And I'm just marking in some of the other values that we have here. 1 foot per 10 inches tall. How long is this? This is going to be 15 minus 6, which is 9 feet. And again, for 1 foot long, we have 10 foot rise. 2 foot long, we have 20 foot rise. How much of a rise do you have for 9 foot long? It's going to be 90 inches rise. And what is 90 inches in feet? Maybe I should have just left these in inches. I don't know. 90 inches per foot. Well, that's going to be 1 foot for every 12 inches. And that'll give you a value.